In this video, we're going to use the node voltage method to find the voltage VO, which is the voltage across this 1K resistor. Now we should know by now, anytime we're using the node voltage method, the very first thing we want to do is to identify the essential nodes. So we know this is an essential node. I'm going to label this node 1. We know this is an essential node. I'm going to label this node 2. We know this is also an essential node right here. I'm going to label this 3. We know this is going to be an essential node right here. I'm going to label this 4. And we have one more essential node at the bottom here. But as you can see, they already gave us a ground. So therefore, node 5 is going to be our ground node or our reference node. Now we know we're going to be using the node voltage method. So we want the voltage at each node, right? So we want the voltage at each node. Alright, so let's start with node 1. When we start with node 1, before we write the node voltage equation, we can see that we have a voltage source in the branch by itself, right? Which means the voltage at node 1 is going to be the same voltage that is in this voltage source here. Therefore, we can say V1 equals positive 12 volts because of the polarity. So we know V1 equals 12 volts. Now this isn't our answer, but I'm just going to circle it. So now we can do the node voltage equation for node 2. Remember, we're always going to assume that the current is going to be leaving this particular branch. So we're going to assume the current is going to flow in this direction here, in this direction, and in this direction. So we're just going to assume the current is leaving the node. Now when we start to write the node voltage equation for node 2, right, we're going to have V2 minus V1 over 2000 plus V2 minus V4 over 2000 plus we have V2 minus V3 over 1000 plus, so we're going to have negative 2 times 10 to the negative 3, and all of that equals 0. Okay? Now when we start to simplify this now, we know the LTD is going to be 2000, so we're going to multiply each term by 2000. When you multiply the first term by 2000, it's going to cancel out. So we're going to be left with V2 minus V1 plus the second term is going to give us V2 minus V4. The third term is going to give us 2V2 minus 2V3. And the fourth term is going to give us minus 4. And that's going to equal 0. So when we start to simplify this now, we're going to get negative V1 plus 4V2 minus 2V3 minus 4 equals 0. Now remember, we just found V1, which is the voltage at node 1, and we know that's going to be 12 volts. So we can substitute 12 volts into this equation. We can say negative 12 plus 4V2 minus 2V3 minus 4 equals 0. Therefore, we're going to be left with 4V2 minus 2V3 equals positive 16. So this is one of our equations, and this is going to be the node voltage equation at node 2. Now let's write a node voltage equation for node 3, right? So when we start to write this now, let me come down here. So we have node voltage at node 3. So we're going to assume that the current is leaving this node, right? So it can go this way, or this way, right? Let me just erase these arrows. So now we're going to take the difference in voltage between V3 and V2. So we're going to have V3 minus V2 divided by the resistor, which is 1000. That's going to give us the current in this branch. Then we're going to have V3 minus V4 divided by 1000. So we have plus V3 minus V4 divided by 1000 plus we're going to have the current in this branch is going to be V3 divided by 1000. So we have V3 divided by 1000. And all of that equals 0. So when we simplify this now, we can multiply each term by 1000 to get rid of this denominator. So when we multiply each term by 1000 now, we're going to get V3 minus V2 plus V3 minus V4 plus V3 equals 0. We can simplify this now to be negative V2 plus 3V3 minus V4 equals 0. Okay, so this is another equation, and this is going to be the node voltage equation at node 3. Now we can write the node voltage equation for node 4, right? We're going to assume the current is going to be leaving this node. So we're going to assume the current is going to flow in this direction, and in this direction. So we're going to have V4 minus V1, right? So we have the node voltage at node 4. We have V4 minus V1 over 1000 plus we have V4 minus V2 over 2000 plus we're going to have V4 minus V3 over 1000. And all of that is going to equal 0. We know the LCD is going to be 2000, so we're going to multiply each term by 2000. So that's going to give us 2V4 minus 2V1 plus V4 minus V2 plus 2V4 minus 2V3 equals 0. When we start to simplify this now, we're going to get negative 2V1 minus V2 minus 2V3 plus 5V4 equals 0. Now we know the value of V1, that's going to be 12 volts. So we can substitute 12 volts into this equation. So that's going to give us negative 2 times 12 minus V2 minus 2V3 plus 5V4 equals 0. So that's going to give us negative V2 minus 2V3 plus 5V4 equals 24. So this is going to be our equation for the node voltage at node 4. Now when we look at this, we have 3 equations, right? So we have 3 different equations. Hold up, I made a mistake somewhere. I want us to notice something. I missed this minus V4. So let me write that in. So we're going to have, let me just move all of this. So we're going to have minus V4 here. Minus 4 equals 0. Minus V4 minus 4 equals 0. Minus V4 equals 16. Okay, so we have 3 different equations, and all 3 of these equations have the same exact unknowns: V2, V3, and V4. V2, V3, V4. V2, V3, and V4. So we can just use the matrix method, and it's going to be a 3x3 matrix, and we're just going to plug that into our calculators and solve for the unknowns. Okay, so we're going to have a 3x3 matrix. we know the unknowns is going to be V2, V3, and V4. Okay? Alright, so let's start to fill in this matrix. For equation 1, we're going to have 4V2 minus 2V3 minus 1V4. So we have 4 minus 2 minus 1, and all of that is going to equal positive 16. So we have positive 16. Now for equation 2, we're going to have negative 1, positive 3, negative 1. So we have negative 1, positive 3, negative 1, and all of that is going to equal 0. So we have 0. Now for equation number 3, right, which is node 4, we're going to have negative 1, negative 2, and positive 5. And that's going to equal 24. So we're just going to take the inverse of matrix A and multiply it by B. And when you do that, that's going to give you V2 equals 9.37 volts. V3 equals 6.17 volts. And V4 equals 9.14 volts. So we know the voltages at each of these nodes. Therefore, to find VO, which is the voltage across this 1K resistor, we know that's going to be the same voltage at node 3. So because we know the voltage at node 3, we know V3, which is the voltage at node 3, is going to equal VO. So we can write this to be V3 equals VO. Therefore, VO equals, we know the value of V3, and that's going to be 6.17 volts. So the voltage across that resistor is going to be 6.17 volts, and that's going to be the same voltage at node 3. So V3 equals VO.